Hello everyone, welcome back to Interview Buddies. In today's video, we are going to talk about Fibonacci sequence. This is a very commonly asked interview question, and it gets a little complicated around time space complexity if you haven't solved it beforehand or haven't worked on this problem. On my screen, I'm highlighting a sequence. It says 0 1 1 2 3 5 8. So basically every third digit here is a sum of last two. So 0 plus 1 makes 1, and 1 plus 1 makes 2, and 1 plus 2 makes 3, and so on. So this is kind of a sequence. It is derived from a formula. So formula says that f of n is equal to f of n minus 1 plus f of n minus 2, a function of n minus 1 plus function of n minus 2. It starts with the base case, which says that f of 0 is 0 and f of 1 is 1. And using this formula, it's kind of very straightforward and easy to calculate the Fibonacci sequence, and I'll show you it in a minute. But it gets complicated if this n is kind of large, right? So for example, if how we calculate f of 2, it's a function of f of 1, and f of 0, which is 1 plus 0 is 1. So f of 2, so value of second digit in the sequence is 1. So you can see 0, 1, and 2. So this is the second digit, right? And so on. So how we calculate it? Basically, I already wrote this down here. So it says that return the function of n minus 1 plus function of n minus 2, and we just add if n is kind of less than equal to 1, then return n, right? Else return fib of n minus 1 plus fib of n minus 2. So this sequence or this function or this piece of code here will calculate the Fibonacci sequence pretty easily. And we can do this like create an object of a class Fibonacci, call as fib equals to new Fibonacci, and then for int I equal to 0, I is less than, let's say, 5 or 10 here, and I plus plus, and then we call it fib dot fib, and we pass every time I, and it will return a value. So let's say int val, and we print out this system.out.print val. Okay, so this is the like the simple implementation of Fibonacci sequence. Here it will print the numbers kind of like this. Okay, so let's run this program pretty quickly, and a little bit more formatting here, space, and that's it. So if I run this one, so 0 0 1 1 2 3 5 8, so it printed like up to 10 values in the sequence. So that's how it works, but it gets a little complicated. So for example, if your n is large, so for a large n, let's say n is like this much, so how it will go? So this program will not function kind of efficiently. Like in this case, the runtime of this will be O of 2 raised to the power n. This will be the runtime for this particular functioning program here, right? And most of the interviews are kind of focused on how you can improve or how you can make it more efficient if the value of n is very large. So how you will do that? So let's write another piece of code, and we will call it memoization or tabulation, because that's a method. So I'm going to write it here. Memoization, Okay, so public int fib new, or let's say fib improved. Okay, how we do that? We create an array and let's name it fib nums. Okay, and it's of long type, and we make it, give it a value of n plus 1. Okay, and then we define the base cases. So we say that fib nums 0 equal to 0, and again fib nums 1 equal to 1. Okay, so these are the base cases as we discussed before. Okay, now we iterate our array, and how we do that? We start from 2. For int I equal to 2, I is less than equal to the value of n and I plus plus. Okay, and then fib nums of I, right? We already have filled in 0 and 1. Now we need the value at 2. So it will be fib nums I minus 1 plus fib nums I minus 2. Okay, so that's it. So that's the whole iteration of this number, and it will create the whole sequence, and it will store the results in this long array. And here we will return this the last or the nth digit, right? So we'll say fib underscore nums and then return the n. But you can also print the whole sequence by just printing the numbers here or iterating this fib nums array right here. So for example, but before that, let me just quickly run this program so that you understand what's getting printed. So I'm just calling fib improved, and let's say if you want to print 6th number in the sequence, right? Let's copy it. Okay, and I'm going to comment this out to avoid any confusion. So okay, so a 6th number of the sequence is 8. I don't know where my example went, so it would be like 0 1 1 2 3 5 and 8. So 0 1 2 3 4 5 6 7, but it's an array, so index start with 0, so it's like 8. So answer is 8, right? So that's how we can improve it. We can improve the performance, and we can print the nth digit. And how you can print the whole array here is just by iterating the array. So for long num, you can say fib nums, and then you can just print the number here. Okay, so let's run it again. So yeah, that's the whole series printed here till 8. So the time complexity for this code is O of n, and space complexity is also O of n. So this is kind of a improved version of Fibonacci sequence. So if you get something like this in an interview, make sure you kind of optimize the algorithm so that it's not just the straightforward brute force code. That's all for today. Hope you like this video, and don't forget to hit subscribe button. Thank you very much.